Hi students, today we will discuss the dependence of temperature on the resistivity of a conductor. So as we know, here resistivity rho is equal to rho naught 1 plus alpha delta T. In this case, here alpha is known as temperature coefficient of resistivity So you already know this resistivity depends upon the nature of the conductor. So in the nature of the conductor, basically we deal with the electron concentration and that is your the average relaxation time. So you already know from our previous classes that rho is given by m upon n e square tau. So the resistivity is inversely proportional to the average relaxation time and also inversely proportional to the concentration of the charge carriers, that is the electrons. So again we know your resistance is equal to R is equal to rho L upon A. So for a given conductor having a fixed length or cross sectional area, we can say that R is directly proportional to resistivity. So this formula can be modified to represent your R. So that will be R is equal to R naught into 1 plus alpha T, right? And similarly, we can also convert this formula like R minus R naught will be equal to here R naught alpha T. So this will be R naught alpha T, right? So this way we can find out the resistance value at a particular temperature if at 0 degree Celsius its value is given, and the coefficient of the resistivity, that is the temperature coefficients, that also will be given. So out of these parameters, whatever given to you, you can solve this question easily. So we'll discuss a question. So now you see, so now we'll solve this question. So in this question, you can find that the resistance of the platinum wire of a platinum resistance thermometer at the ice point. So what do you mean by the ice point? Can you tell me? Your ice point, that means that is your 0 degree Celsius. Similarly, the resistance is 5 ohm. And at a steam point means you know that is 100 degree Celsius. So at 100 degree Celsius, the resistivity, that resistance is 5.23 ohm. So what is asked in the question? In the question it is asked that the resistance will be 5.795 ohm at what temperature? So you can see here, by using the resistance at a given temperature, if the resistance is given at 0 degree Celsius, we can use the formula. So here two cases are there. 0 degree it is given, 100 degree it is given, and at T temperature it is given. So we have to find out the temperature. So to solve this type of questions, first write down the data given. So here R naught is given as 5 ohm and R at 100 degree Celsius it is given as 5.23 ohm and R at a given temperature is given as 5.795 ohm. So what we have to solve here, we have to find out the temperature. So you see here, we'll be using this formula. Like here R minus R naught will be equal to R naught alpha T, right? So by having this pair and by having this pair, we can get two equations, and by dividing these two equations, we can solve this question. Now we see how. So first part, this will be R100 minus R naught will be equal to R naught alpha T. Similarly, if we consider these two cases, so this will be RT minus R naught will be equal to R naught alpha. This is T1, this will be T2. So if we take the ratios, then we'll find this R naught cancels out, alpha cancels out, and we can put the value. R100 is your 5.23 minus your R naught is equal to your, that is 5 upon, what is RT? RT is 5.795 minus 5. So this will be T1 upon T2. T1 in this case will be 100 and T2 we are not knowing, we need to find out. So by taking this, we will be getting 0.23 by 0.795, we will get 100 upon T2. So the value of T2 will be equal to, we can find here, T2 will be equal to, that is 100 into 0.795, so that is 79.5 upon, this will be 0.23, here we will get 0.23, so the value we can get. But here you will see